My name is Sean. My physics conceptual video topic is kinetic theory of gases. Contents. Introduction. What is kinetic theory of gases? Ideal gas information. Assumptions of kinetic theory of gases. Postulates of kinetic theory of gases. What are the three main components of the kinetic theory of gases? Derive gas laws from the different kinetic theory of gases. Introduction. In the 19th century, scientist James Clerk Maxwell and Clausius developed the kinetic theory of gases to explain the behavior of gases. The theory explains gas as a collection of tiny hard spheres that interact with each other and with the surface of the wall. The spheres represent the gas molecules and they behave according to the laws of motion developed by Newton in the 17th century. It describes how molecules influence gas characteristics such as temperature and pressure. It also explains why gas follow Moore's law. What is kinetic theory of gases? Kinetic theory of gases states the gaseous particles are in the constant motion and undergo perfectly elastic collisions in collection of gas particles. The average kinetic energy is directly proportional to observed current. According to this theory, the gas molecule is composed of a huge number of tiny molecules compared to the distance between them. The kinetic theory of gases is necessary for clarifying the process of wrapping particles by the diffusion mechanism. Let's learn about the relation between these macroscopic properties with the microscopic phenomena. Ideal gas equation. The ideal gas strictly analysis to the basic principles of Moore's law. Charles' law, K. Lucius' law, Avogadro's law. Each ideal gas strictly follows the uh, four laws: the Moore's law, Charles' law, Lucian's law, Avogadro's law. And an ideal gas is a gas that contains a group of randomly charged particles that remain only in an elastic position. Means gas molecule and a this container bears the gas molecule. The relationship between pressure P, volume P, and absolute temperature T of a gas can express the ideal expression. The ideal gas equation is given below. PV is equal to nRT, where P is equal equal to temperature, N is equal to number of moles, R is equal to gas consumption is equal to 8.314 into 2 1 mole 1. Now, any gas that follows this equation is called ideal gas. This equation 8.314K. This type of equation which follows any gas that follows this equation is called an ideal gas. Assumptions of kinetic theory of gases. Following are the kinetic theory of gas assumptions. All gases are made of molecules that are and consistently moving in random directions. The separation between the molecules is much greater than the size of molecules. When a gas sample is kept in a container, the molecules of the sample do not exert any force on the walls of the container during the collision. The time interval of a collision between two molecules and between a molecule and the bond is considered to be very small. All the collisions between the molecule and even between molecules and walls are considered to be elastic. All the molecules a certain gas sample obey the laws of motion. If a gas sample is left for a sufficient time, it eventually come to a steady state. The density of the molecules and the distribution of the molecules are independent of position, distance, and time. Assumptions of magnetic theory of gases. Following are the kinetic. Following are the kinetic theory of gases assumptions. All gases are made of molecules that are constantly and persistently moving in random directions. The separation between the molecules is much greater than the size of the molecules. When a sample space is kept in a container, the molecule of the sample do not exert any force on the walls of the container during the collision. The time interval of a collision between two molecules and between a molecule and the wall is considered to be very small. All the collisions between molecules and even between molecules and walls are considered to be elastic. All the molecules in certain gas obey the laws of motion. If a gas sample is left for sufficient time, it eventually comes to state, the density of the molecules, and the distribution of molecules are independent of position, distance, and time. Postulates of kinetic theory of gases. Following are the kinetic theory of gas postulates. The space volumes to molecules ratio is negligible. There is no force of attraction between the molecules at normal temperature and pressure. The force of attraction between the molecules builds when the temperature decreases and the pressure increases. There is a large space between the molecules, resulting in continuous motion. The free movement of molecules results in a motion which is perfectly elastic. The molecules have different kinetic energy due to random movement, but the average kinetic energy of these molecules differ the temperature. Molecules exert pressure on the walls of the container. Hence, the movement of the molecules results collision and the kinetic due to random movement, but average kinetic energy of the molecules differ the room temperature. What are the three main components of the kinetic theory of gas? Following are the three main components of the kinetic theory of gas. When molecules collide, when molecules collide with each other, no energy is gained or lost. The space occupied by the molecules of the gas in such a container is very negligible. These molecules always have linear motion. Derive gas laws from the kinetic theory of gases. Boyle's law states that P on P 1 by V if P is equal to constant derivation. We know from the kinetic theory of gases that P is equal to 1 by 3 Pc square is equal to 1 by 3 into m by v c square. PV is equal to 1 by 3 mc square. Also, we know that 1 by 3 mc square is equal to RT. PV is equal to RT. Here, R is equal to constant. P is equal to constant. Then PV is equal to constant. R. P is equal to 1 by V. Charles' law, which states that for a given mass of gas, the volume of the gas is directly proportional to the absolute temperature of the gas. If the pressure is constant, E dot V proportional to T. Derivation, we know that PV is equal to 1 by 3 MC2 is equal to 1 by 3 MNC2, where N is equal to Avogadro's number. Also, we know that mean Ke of a molecule is E is equal to 1 by 3 Mn by V C square. V is equal to 1 by 3 M 2 N1 C1 square by D. For gas A, this is equation 1. For gas B, D is equal to 1 by 3 M2 N2 C2 square by V. This is equation 2. From equation 1 and 2, we get N1 N1 C1 square is equal to N2 N2 C2 square. This is equation 3. Also, we know that 1 by 2 MC square is equal to 3 by 2 KT. Therefore, 1 by 2 M1 C1 square is equal to 1 by 2 M2 C2 square is equal to 3 by 2 KT. Or M1 C1 square is equal to M2 C2 square. This is equation 4. 3 divided by 4 gives N1 is equal to N2 in school. The Graham's law of diffusion of gas. It states the rate of diffusion, diffusion of gas is inversely proportional to the square root of density of gas. Derivation. We know that P is equal to 1 by 3 Pc square. C is equal to under root 3P by P. C proportional under root 1 by P if P is constant. Also, we know that RMS velocity is directly proportional to the rate of diffusion of the gas. That is C proportional to R proportional to under root 1 by 3, proportional to under root 3 by M. Thanks.